Hello everyone. In this section, we are going to learn about the chain rule. In many situations in calculus, functions are built from other functions. When one function is placed inside another function, we call it a composite function. The chain rule is a rule that helps us find derivatives of composite functions. It works by connecting the derivative of the outside function with the derivative of the inside function. So today, we will first look at what composite functions are, and then we will see why the chain rule is necessary. Let's start with the idea of a composite function. A composite function is simply a function inside another function. In other words, we take one function and plug it into another function. Let's take a look at an example. F of x equals sine of x squared. Here we actually have two functions working together. The inner function is the expression inside the sine function, that is x squared. So the inner function is x squared, then we apply the sine function to that result. So the outer function is sine of something. This something is the result of the inner function. You can think of it like this. First, we square x, and then we take the sine of the result of x squared. Let's look at another example. F of x equals 3x plus 4 raised to the fifth power. Again, this is a composite function. Inside the parentheses, we have 3x plus 4. So that is the inner function. The entire expression is raised to the fifth power. So the outer function is the power function. So we can identify the outer function is something raised to the fifth power. And the inner function is 3x plus 4. Again, think of the process step by step. First, we compute 3x plus 4. Then, we raise the result to the fifth power. So the inner function happens first, and the outer function happens second. Now, let's talk about why we need the chain rule. In many situations, when one quantity changes, it causes another quantity to change. For example, look at this chain of relationships. Here's what is happening step by step. First, x changes. When x changes, x squared changes. Then when x squared changes, the value of sine of x squared also changes. So the changes happen in a sequence, like a chain. That is actually where the name chain rule comes from. Let's fill in the statements. Change in x affects x squared. Change in x squared affects sine of x squared. Because these changes happen one after another, when we take a derivative, we must account for both changes. And that is exactly what the chain rule helps us do. The chain rule tells us how to compute the derivative when one function is inside another function. In the next part of this section, we will learn the actual formula for the chain rule and practice using it.